The next unusual situation we're going to look at together here is what you would call infinite solutions. We just saw equations where there are no solutions, and the other weird situation is when there are infinite solutions. We call this an identity. And the reason why I call it an identity, the reason why I call it infinite solutions, you'll see when we do some examples, it makes sense. It's called an identity because really you've got an equation where both sides of the equation are identical. Sometimes it's hidden that they're identical, but they're identical to each other. And we say that they're infinite solutions because absolutely any number will work. Okay, so let's say you have an equation like this. 5x minus 5 equals 5x minus 5. Let's first priority get the x's together, right? So we're going to subtract 5x from the left. I'm going to subtract 5x from the right. That leaves with minus 5 equals minus 5. I could say, well, let me add 5 to both sides. I get 0 equals 0. 0 equals 0, that's just true, right? That's just always true. And when you see these two here, you might want, I have a habit of drawing a little smiley face there because it reminds me that 0 equals 0 it's not no solutions, right? This guy isn't sad. He's not getting no solutions that nothing's working. He's happy because absolutely everything's working, right? You could try plugging in absolutely any number to this equation and it'll work. Like, let's say we take 2 as a number, right? I'm going to replace x with 2. I'm going to rewrite my equation. Every time I see an x, I put brackets and I put the number 2 in there instead, right? So I got 5 times 2 over here, 5 times 2 minus 5, and then 5x minus 5, 5 times 2 minus 5 over here. So now I simplify. 5 times 2 is going to give me 10 minus 5 over here. Over here, 5 times 2 gives me 10 minus 5. And then I simplify again. I get 5 equals 5. This is me verifying, right? This isn't me solving the equation. I've already solved the equation. When I plug this number in, I'm getting 5 equals 5, which is true, right? Now notice the two sides of the equation here are absolutely identical. That's why we call it an identity. And when you have an identity, it means there are infinite solutions, right? Anything will work. So let's look at page 15 in your unit book. And again, this is something you're going to have finished and filled in when you hand in your work. So make sure to follow along with this example right now on page 15. Page 15 gives you this example. Minus 12x minus 4 equals minus 4 times 1 plus 3x. Now you're looking at this and it might not be obvious that these two sides are actually identical to each other. They're kind of secretly identical. So you need to do some math here to get to the point where it starts to become clear that they are identical, right? So let's simplify the right-hand side. I got brackets here. Let me distribute the minus 4 into the brackets. Minus 4 times 1 is minus 4. Minus 4 times 3 is minus 12. X, so I've got minus 12x minus 4 equals minus 4 minus 12x. Now it's a little more obvious that they're identical. But I'm going to go to the step of getting the x's together. I'm going to add 12x to both sides because this feels a lot like no solutions, right? So the two are the opposite of each other, but they kind of look the same a bit. So let me add 12x to both sides. That gives me minus 4 equals minus 4. I'm going to add 4 to both sides, and I get 0 equals 0. And I'm going to draw a little smiley face because this guy's happy. He's got infinite solutions. Everything in his life is working. Absolutely anything will work for this guy. He's very happy, okay? So underneath you would write identity or infinite solutions. And what you've got in those cases is just an equation where absolutely any value for x will make the equation work. You can plug in any value for x in that equation and it will produce a true statement. And when this happens, it means your equation has infinite solutions. And we also call that an identity. So that's what you would write underneath the equation. You either write the word infinite solutions or you could write the word identity. They mean the same thing. Now, if you're saying to yourself, I'm a little confused because this really looks a lot like what we saw with no solutions, you'll see there's an important difference. In no solutions, when we were doing equations with no solutions, you had the same coefficients on both sides but different constants. Here, with infinite solutions, you'd have same coefficients on both sides again, but you've got the same constants, right? Like if you look at this example of an identity, 2x plus 2 equals 2x plus 2. It's identical on both sides. I got same coefficients, 2x, 2x. The 2 is the coefficient here, so 2 and 2 in front of the x are both the same. And I've got the same constants, plus 2 and a plus 2. If this said 2x plus 2 equals 2x plus 3, that would be no solutions because I'd have the same coefficients and different constants. But here I got same coefficients, same constants. That means it's an identity. Here again, 7x minus 2, 7x minus 2. Same coefficient in front of the x, right? 7 here, 7 here. Same constants, minus 2 and minus 2 on both sides. This is an identity. absolutely any value for x will make this true. You plug in 973.49 on both sides here, you'll get the same answer on both sides, which means that it works. Okay. Now, sometimes it can be disguised. It might not be obvious that you're dealing with an identity because you can't quite see that you've got the same coefficients and the same constants. But really all you're doing here is you're like this here, you see if you simplify this by one step, you end up with the